So the format that I'll be following today is I'm going to run through all of the eFundi lessons and highlight things that you don't need to study for the exam. You're welcome to post questions to the chat during the course of the session. I won't see them immediately as I'm going through them, so we'll address those questions once I've run through all of the 7 study units. So any questions you have, you're more than welcome to post them in the chat, and then I'll cover them directly afterwards. Okay, so we'll start quickly with study unit 1, which is Introduction to Operating Systems. So as part of this study unit, I'm going to highlight that there's a few changes from past exam papers. For those of you that study using exam papers, use them to exercise as practice. For this year's exam paper, I've included a number of multiple choice questions. I've requested that these be presented to you in a normal eFundi tests and quizzes format so that you can tick the questions as you normally would. However, these are new questions that you've never seen before, and they'll be exactly the same as the ones the contact students receive. So on that note, I'd just like to clarify this because I did not do it with CMPG 315. Due to the balancing with the modules, specifically where this module's curriculum and semester was designed to for your participation mark to only account for 30% and for your exam to contribute 70%. There will be a slight change to the way in which the exams are marked. That change is just that there will be no difference in the way that the distance and the contact exams are marked. So this was a bit poorly communicated from my side with CMPG 315 this first semester, where it seemed the intention that was communicated was that I will be marking the distance papers more strictly than the contact papers. This was not the case and is not the case now. So usually I mark the distance papers a little bit differently due to the differences in presentation style and weighting, and also due to the fact that unlike the contact students, you aren't exposed to written tests during the course of this semester. However, due to the changes in the balancing, the way that you'll be marked during the exam will be exactly the same as for the contact students. The only difference is that because you're writing an online paper, that will have an impact on the way you submit your questions. But the way in which I'll be evaluating, the way the memo will be used, all of those will be exactly the same as for the contact students. And that's also why I'll be giving you the same demarcation as I give the contact students. So with study unit 1, most of the contents of study unit 1 that you need to know will be evaluated using the multiple choice questions. So the basic background of what an operating system is, the operating system layers, these are all things that you need to know as background. But it's unlikely that you'll see direct questions from this. From the history, interesting to know, important to know, but there aren't any direct questions about history either. With your various components of a computer, program counter, stack pointer, all of these are important to know as they are relevant to topics in other study units, but it's unlikely that you'll see direct questions from this. Same with things like your direct media interface, Northbridge, Southbridge, all of these things. The first thing in this lesson that is very important for you to know is the boot procedure. Okay, so the way the boot procedure is asked is usually as part of a question that combines topics from the first study unit with the fourth study unit on file systems. So typically when this question is asked, you need to provide this as a diagram that's integrated into the file system diagram. So you need to provide one diagram and not, say, for instance, the file system diagram and then a separate one showing the boot procedure, Or for instance, the file system diagram with just this as a list at beneath the diagram, that'll all be marked incorrectly. When I ask for a diagram that shows the file system and the boot procedure, it all has to be one diagram. So make sure that you don't give lists, you don't just add in marks in the diagram and then connect them to these steps below it. Make sure it's all one integrated diagram. Then for your comparison between operating system types, so I would like to clarify here, as I've had this question in the past, Windows and Mac OS are not operating system types. They are examples of operating systems, specifically personal computer operating systems. Same with Android and what would be Symbian for the older phones. Things like those are then handheld operating systems, handheld computer operating systems, examples of those. So when you study the operating system types, make sure that you can make that distinction. A type describes a broad category and not a specific example. Now, the good news is that you will not be required in this year's exam to provide something like a table in which you compare these operating system types using their various features, but you will receive multiple choice questions in which you need to compare these to one another. So you do need to understand their various features and attributes so that you can basically compare them and answer questions from their various features, so that if, say, for instance, I ask you, give you a question, example would be something like, what amongst the following does a mainframe operating system have that a multiprocessor operating system does not? Just to use an example. And then you'll be given a list of options. So for the multiple choice questions, also note that none of the questions have as little as 4 options. If memory serves, the fewest options are 6, and they go up to something like 10 or 12 for the potential answers on the multiple choice questions. So they differ depending on the question, but they can be, they probably will be a bit challenging if you're used to seeing 4 answer multiple choice questions, but just make sure that you understand the various topics and should be fine. Then things like processes, files, protection, security, all of these are topics that are important for further study units, but not as important for study unit 1, which is just introductory. So focus more on these topics in the context of the later study units. This diagram about about system calls, important to know, important to understand. You will not be required to give a diagram describing how a system call functions. So questions about system calls also incorporated into the multiple choice questions. And then finally, for study unit 1, the various types of kernels you get, monolithic, layered, microkernels, client server. Interesting to know, none of this is asked in the exam as such, so you don't need to worry about these. Okay, then on to our second study unit on processes. Okay, so processes has the largest number of hours assigned to it. It's also one of the most important concepts in operating systems. So you'll get a fair number of questions from from processes. These will include CPU scheduling. So you will be required to apply CPU scheduling to a given example, much like the examples provided on eFundi. So that's typically the format you'll need to provide your answers in. It will be for single processor systems, so you don't need to worry about multiple processor implementations. Just a single processor with all of the processors running there. It will be a standard 5 process, 20 cycle question that you need to answer. and any one of the indicated algorithms in this lesson, we'll run through them in a moment, can be asked. So typically the question is you need to apply the scheduling for 5 marks, and then you need to calculate one of the 3 metrics, as discussed also in, I believe it's the video I added to this lesson. You need to be able to calculate all 3 of those metrics, but then I'll indicate one. You calculate those metrics for each process, and then it's 1 mark for each of those as well. Do note that I do not mark along with mistakes. So if your scheduling is wrong, then your metrics have a good chance to be wrong as well. Okay, then for study unit 2, you do need to know what the process is, the process model, how you would initialize a process, create it, how they would exit. But the most important part here is this diagram: ready, running, blocked, with the 4 transitions. I can give you this diagram in any format, any arrangement. I can also give you more circles than is shown here with additional transitions, and you'll need to be able to identify the ones that don't belong. When I give you a question like this, it's usually followed up with a question in which I give you a scenario, and you need to identify which process state transition is relevant to that scenario. It is crucial that you recognize that when I give you the diagram, such as this diagram, in the exam, the numbers are relevant to that diagram. So the numbers here, this 1 from running to blocked, and 2 from running to ready, 3 from ready to running, and 4 from blocked to ready, those are applicable to this diagram. But this is not necessarily going to be the diagram you get in the exam. So I can, for instance, ask you, I can remove running, blocked, and ready, and then you have to add that back into the diagram in any which way I've structured it with the various transitions. So make sure that when you answer your question, those scenario-based questions, that you keep these specific numbers in mind, because those will be the ones that will be marked correct or incorrect. Okay, then for threading, threading is interesting to know, important to know. You also won't get a direct question on threading in which you need to give me a diagram, say, for instance. I may ask you to discuss the implications of threading, maybe ask you what threading is. If you implement it in a process, what will be the impact of implementing threading? But I would ask you specifically to say, for instance, give me a diagram discussing or describing how a web server process would work. So you won't get a question like that. Okay, same with the type of threads you get, maybe a theoretical question, but it won't be a diagram style question. Then the next one, inter-process communication, is very important. You will get questions on inter-process communication and more specifically race conditions. So usually the way this is asked is you need to explain how you would avoid or address race conditions by discussing various techniques. Okay. Now, one thing I'd like to point out here from this lesson, this is a description of how you could potentially get a race condition or encounter a race condition. This is followed by the conditions that are necessary for a race condition to occur. Note that none of these are techniques. Okay, so these are just conditions. And from here, we start seeing our techniques. So the various techniques that you need to be aware of are, you can disable the interrupts, you can lock variables, you can use strict alternation. Strict alternation has busy waiting as a bit of a negative feature. Strict alternation you can improve by implementing Peterson's solution. So strict alternation on its own is one technique. Strict alternation using Peterson's solution is a second technique. Using test and set lock instructions, that's a new next technique. Then you get your semaphores, you get your mutexes, you get your monitors, you get message passing, and you get barriers. Now, what you also need to be aware of is you need to understand these techniques to the level where if I specify a condition for the techniques that your techniques have to adhere to. So let's say, for instance, a very common one I asked, and I asked it in this year's semester test, I believe it was, is you need to discuss 4 techniques that are fully implementable in user space. So what that means is you cannot make use of any technique for which you require direct kernel access or special hardware. So disable interrupts is not an acceptable answer there, because in order to disable interrupts, you need kernel access, because this is a system-wide action. You also can't use TSL instructions because that requires special hardware. You can't implement a hardware solution fully in software. So that one's also not viable. Semaphores, mutexes, viable. Monitors are viable provided that your programming language allows for it. So the functioning and features are language dependent. Okay. Same with message passing. You need to make sure that it's implementable, that your operating system, for instance, allows for message passing. So it's technically not always fully implementable in user space. So there's caveats there. And of course, barriers will also depend on the solution you're proposing. Would barriers be appropriate for just general race condition avoidance? So you'll need to consider these types of things depending on the way in which the question is asked. Okay, so this can be anything from you needing to provide 2 techniques all the way up to 4 or 6. And then it'll typically be 2 marks for a correct description of the technique. If I ask you to specify the techniques as well, so when I don't specify the technique name, then you also need to provide the technique name. If the technique name is incorrect, then you lose a mark. Okay, so just keep that in mind. So if you have a perfectly correct description, but the incorrect name, you're only going to get 1 out of 2 because you lose a mark for that incorrect name. But if the name is correct and the description is correct, you'll get your 2 marks for the correct description. Okay, then finally we're on to scheduling. So like I discussed, scheduling will be very similar to the examples provided on Efundi. Unfortunately, I don't think previous exam papers have included the CPU scheduling questions, but the examples I sent to your tutor to discuss with you those papers, I believe the semester test included the CPU question as part of the paper. So then it'll give you an idea of what it looks like. And then for the actual applications, you should be fairly familiar with how to perform CPU scheduling using specific algorithms. So I don't ask you direct questions on things like batch interface real time, the goals, the throughput, burst time, wait time, turnaround time. These are all important for your application as well as your metric calculations. So what you need to know when it comes to actual algorithms that you need to know and need to be able to apply: first come, first serve, both with priority and non-priority, as well as your non-preemptive and preemptive. Shortest job first, priority levels as well, your shortest remaining time next, also with your priority levels. So make sure that you can apply those in the correct way. all of the examples that are on eFundi are examples of algorithms you need to be able to apply. Then your round robin scheduling. Round robin is never non-preemptive, so it will necessarily be preemptive, but make sure that you can use the normal preemptive one as well as the one with the priority levels as well. Then your guaranteed scheduling, lottery scheduling, and fair share scheduling. Good to be aware of them, but they are not asked as part of an application question in the exam. So take note of them, but you don't need to be able to apply them. Okay, then on to study unit 3 on memory management. So for memory management, the primary core, I'm just going to jump off with this. The primary core of study unit 3 is paging systems. Okay. So you do need to know everything about main memory, your random access memory, the difference between volatile and non-volatile memory, how you would do memory management without abstraction. No direct questions on this. So you don't need to worry about knowing this diagram in particular detail. Good to be aware of, but not important for the exam. Same with swapping. And then you get to your base and limit registers. Very simple way to start introducing a bit of abstraction by decoupling your physical address from your application's addresses. But also up to this point, all background knowledge, good to know, but no direct questions on this. Same with things like memory compaction. So where it starts being important is with your virtual memory concepts and in particular paging systems. So when you prepare for your questions on memory management, this particular diagram is a good illustration of what happens when you convert your virtual pages into your physical addresses, but it is extremely unlikely that you will get a question that requires this diagram as an answer. The same with the operation of an MMU. It's also very unlikely that you'll be getting this diagram. This one, on the other hand, is very important to take note of. What's also important is that you'll notice that this particular part of the lesson, the detail of how a paging system functions is described in quite a lot of detail, and yet the numbers in this diagram aren't highlighted in the lesson itself. What you need to do as part of your preparation is for each of these numbers, go into the theory, go into the lesson, and make sure that you understand what happens at each step. Because when you provide a diagram describing how a paging system works, if it's this diagram, you have to include the steps as part of the diagram. If you just duplicate, basically parrot copy this diagram onto the exam paper, you are going to lose marks, if not all of them. So this is just a part of the answer then, because while this does contain some of the detail, I cannot determine from this diagram what happens here at step 8. I do know that this is when the physical address, so in other words, the frame address, is sent to the page table so that you can have a matching entry that specifies in which frame a particular page is stored, but this is not shown on this diagram specifically. You have to add that as a description as part of your answer when you provide the answer. So make sure that when you're studying paging systems, you actually know how paging systems work. Alternatively, I can also do something like ask you to describe how a paging system works by means of a flow diagram. So this is not a diagram that is included in your lessons. So it's something that you'll need to figure out and be able to draw and sketch when I provide the question for you in the exam. So make sure that your comprehension of paging systems is on that level so that you can answer those types of questions. Then for your multi-level page tables and inverted page tables, both techniques that you can use to optimize your paging system without the use of hardware. Good to know, not asked directly. And now we get to our page replacement algorithms. So first things first, you get 2 second choice page replacement algorithms, and either one of them or both of them are going to be asked in the exam. So these two are the straight up second chance, okay? And the other one is the clock. Now, both of these are second chance algorithms because both of them have an R bit value that can indicate whether or not a page has a second chance. So you will get either one of these or both of them. Okay, but if you get one, that does not mean that the other one is going to be the clock, the other one. So let's say, for instance, you get second chance in the first opportunity. That does not necessarily mean that you're going to see clock in the second opportunity. It could just as easily be optimal. It can be first in, first out, and it can be least recently used. Okay, so make sure that you can use all of these algorithms for a given scenario, given a question. Just like with the CPU scheduling, there's a fixed format for this. You will get a question with 5 frames and 20 page requests. And then you just need to apply the page replacement algorithm there. Unlike with the CPU scheduling, there's no further metrics. So if you do your apply your